Hi everyone. Today we're going to study Laplace transform of standard functions. First, let us define Laplace transform. Suppose that f of t is a continuous or piecewise continuous function. The Laplace transform of f of t is denoted as L of f of t and defined as the L of f of t is equal to the definite integral from 0 to infinity of the function e raised to the negative of the product st times the f of t dt. We denote Laplace transform as L of f of t is equal to capital F of s. With this alternate notation, note that the transform is really a function of a new variable s, and that all the t's will drop out in the integration process. Now let us define exponential order. A function is said to be exponential order if the limit of e raised to the negative of the product st times f of t as t approaches infinity equals 0 or finite. There are conditions for the existence of Laplace transform. Laplace transform of the function f of t exists subject to the following conditions. Number 1, f of t is continuous. Number 2, f of t is of exponential order. Let us see Laplace transform of standard functions. Suppose the function is 1. Laplace transform is 1 over s. In this case, s must be greater than 0. Next, the function e raised to at. In here, the condition is a is less than s. So Laplace transform is 1 over s minus a. Next, the function is e raised to negative at. Again, a must be less than s. Laplace transform is 1 over s plus a. The function t raised to n. In this case, n must be greater than 0. And Laplace transform is n factorial all over s raised to the power n plus 1. Next function is the sine at. Laplace transform is a over s squared plus a squared. What about cosine at? The transform is s all over s squared plus a squared. Then the sine h of at. Laplace transform is a over s squared minus a squared. And the cosine h of at, we have s all over s squared minus a squared. Let us see this example. Find the Laplace transform of the following. Let's begin with problem A. The function is t cubed. We can write the notation to be like this, L of t cubed. Looking at our table, we're going to use this formula. Let us substitute the corresponding values. So we have now 3 factorial over s raised to 3 plus 1. We can simplify further. The denominator becomes s raised to 4, and we expand the factorial. We have 3 times 2 times 1. So the final answer is 6 over s raised to 4. Let us copy the answer opposite problem A. Next is problem B. The function is e raised to the negative 4t. We write the notation L of e raised to negative 4t. In our table, we're going to use this formula. Substituting the corresponding values, we have 1 all over s plus 4. This is the final answer. Let us copy the answer opposite problem B. Next is problem C. The function is sine 4t. Our notation is L of sine 4t. In our table, we're going to use the formula for sine at. Let us substitute the corresponding values. We have now 4 over s squared plus 4 squared. Take note that in here, the a is equal to the value 4. Let us now simplify further this 4 squared. It becomes 16. And this is now the final answer. Let us write the final answer opposite problem C. Then we go to problem D. Our notation is L of cosine t over 2. In our table, we have this formula for the cosine at. Let us substitute the corresponding values. In here, the a value is 1/2. So we have s all over s squared plus the square of 1/2. We simplify the square of 1/2 to be 1 over 4. Then let us simplify the denominator. This s squared plus 1/4 we can write as 4s squared plus 1 all over 4. Then let us simplify this complex fraction. We have now s, that is the numerator, multiplied by the reciprocal of this denominator. So we have 4 over 4s squared plus 1. S multiplied by 4 will be 4s all over this same denominator. This is the final answer. We copy this answer opposite problem D. Now we have problem E. In our notation, we write L of the product sine t times sine 2t. But in our table, we don't have formula for a product. Good thing is, we have this identity that the sine t times sine 2t is equal to 1/2 of the quantity cosine t minus cosine 3t. Substituting the values of the identity here, we have now this notation. Then we are going to show that we are going to put 1/2 outside and then take the Laplace of cosine t minus Laplace of cosine 3t. Then in our table, we can use this formula respectively. Laplace of cosine t will be s over s squared plus 1 squared minus the Laplace of cosine 3t would be s over s squared plus 3 squared. When we simplify the corresponding denominators, we have now s squared plus 1. The other one is s squared plus 9. Let us combine the fractions. And the difference becomes like this. When we simplify our numerator, and then we consider the 1/2 outside, the final answer will be like this. 4s all over the product s squared plus 1 times s squared plus 9. This is the final answer. We copy this answer opposite problem letter E. I hope you learned something from this video. See you again next time.